Here we want to find the critical value z subscript alpha divided by 2 that corresponds to the given confidence level, and the given confidence level is 82%. Okay, so what we want to do is the following. The confidence level is the probability or area where it's 1 minus alpha, where alpha is the complement of the confidence level. It is often expressed as the equivalent percentage value. Now, the critical value is the positive z value that is at the boundary separating an area of alpha divided by 2 in the right tail of the standard normal distribution. So, we want to first be able to find alpha. So, in order to find alpha, okay, it's going to equal 1 minus the 82%, which is the same thing as 1 minus 0.82. And so 1 minus 0.82 is going to give us 0.18. Okay, so now what we want to do is we want to take that alpha and then divide that by 2. So we're going to take that 0.18 and then divide that by 2. So if we take 0.18 and divide that by 2, that's going to give us 0.09. Okay, so ultimately what we want to be able to do is we want to find z value of when 0.09 is the area that's to the right of the normal distribution. So let's go ahead and draw our normal distribution. Okay, so we know that the mean is going to be 0. And so what that means here is that the area that's shaded to the right, in this case, is 0.09. And therefore, this area that's to the right is going to represent 0.09. So the area to the right here is 0.09, which means this area would be 1 minus 0.09, and 1 minus 0.09 is 0.91. And so now what we want to do is we want to find out what is this critical value that has an area to the right of 0.09. So what we're going to do is the following. We want to find, okay, the probability of a z-score, okay, that's going to have an area to the right of 0.09. So we can say greater than or equal to. So what we're going to do is we're going to go ahead and use StatCrunch to find that. So I'm going to open up StatCrunch here. Okay, so ultimately what we want to do is we want to go to Stat and then go to Calculators and then scroll all the way down to Normal. Okay, now keep in mind here that again we have a mean of 0, a standard deviation of 1, and we are using the area that's to the right here. So we want to make sure that we change this inequality sign to be greater than or equal to, and then we're going to put in the area that represents 0.09. And therefore, that's going to give us this critical value, which is the z-score of 1.34. So therefore, this is going to be 1.34, which then gives us our critical value of 1.34. So now we can go ahead and answer our question. So over here, we get 1.34, and there is our answer. So again, just to verify that, okay, we could have put in the area to the left, which is 0.91. So, but in order to do that, we would have to change this inequality to go less than, right? And then if we put in 0.9100, we would get 1.34. But in this case here, remember that the critical value is the positive z value that is a boundary separating an area of alpha divided by 2 in the right tail of the standard normal distribution.